theorem. If the function f(x) is greater or equals to 0 on the interval ab, then the definite integral between ab of f(x) dx is the area under the curve y equals fx above the x-axis between x equals a and x equals b. We already know that there is some connection between area and the definite integral. We want to dig more into that today. First of all, we are going to use the theorem to write an integral for the area under the curve y equals x to the power of 2 plus 3 on the interval 0, 4. When I say under the curve, I mean also above the x-axis. This function is always above the x-axis. It means that f(x) is strictly greater than 0. That's why I can use this theorem with a equals 0, b equals 4 to get that this is the area. So in this case we get a definite integral of x to the power of 2 plus 3 dx between 0 and 4. In general, for any continuous function f on ab, the definite integral between a and b is always the area of the region under the curve above the x-axis between a and b minus the area of the region above the curve below the x-axis between x equals a and x equals b. In short, we will say that the definite integral f(x) dx between a and b is the area above, which means above the x-axis and under the curve, minus the area below. Below means below the x-axis and above the curve. Example, in this picture, I have 3 areas of 3 different regions. A sub 1 and A sub 3 is above the x-axis and A sub 2 is below the x-axis. And that's why the integral of f(x) dx between a and b is the area above minus the area below. We get a sub 1 plus a sub 3 minus a sub 2. Use areas to evaluate the definite integral between -2 and 3 of 1 plus x dx. This is related to area, so first of all we can sketch this. It's pretty easy to sketch y equals 1 plus x. This is just a straight line. Okay, let's see. The a is -2 and the b is 3. And this area is the area above the x-axis and under the curve. And this is below the x-axis and above the curve. Because we have just 2 simple triangles, we can find the area of each one. This definite integral is the area above minus the area below. What is the area above? The base of this triangle is 4 units and the height is 4 units. And the second one has a base of length 1 and height of length 1. So we get that the area above is 4 times 4 over 2 and the area below is 1 times 1 over 2. And when we take the difference, we just get 15 over 2. Let's use this picture to find the value of the definite integral of f(x) dx between -6 and 5. This is the area above, which is a sub 1 plus a sub 4, minus the area below, which is a sub 2 plus a sub 3. Now we have to evaluate each one of those. This is a trapezoidal area. The sum of the bases is 4 plus 2. Look at the upper base is between -5 and -3, and the lower one is between -6 and -2. The height is 4, and we get the height, which is 4, times the sum of the bases 4 plus 2 over 2, which is 12. A sub 2 and A sub 3 are both squares with side of length 2 units, and we get that both of them are 4. And what about A sub 4? This is a region of a triangle with height 4 and base of 3, which means the area is 6. So we get that the total is 12 plus 6 minus 4 plus 4, so the total is 10, which means that this definite integral equals to 10. What is the total area enclosed by the curve, the x-axis, on the interval -6 to 5? In this case, we have to take the integral of the absolute value of the function, because we cannot subtract area, but all the areas are just added up. And we get 12 plus 4 plus 4 plus 6, so the total of the area that enclosed between the curve and the x-axis is 26. And what about this one? Between -2 and 5, we have two areas which are below the x-axis, and one that is above the x-axis. And we get that. And we get -2. If the definite integral between -2 and 5 is -2, it means that the area below the x-axis is larger than the area of the region that is above the x-axis. Let's do a tricky problem. Let's try to evaluate this integral. It's a really advanced integral if you want to evaluate this directly, but we just want to find the connection between this and a given area. So what is the region here? Y is positive because it's a square root of. So let's observe the graph of y equals square root of 9 minus x to the power of 2 when x is between 0 and 3. First of all, from here we get that y to the power of 2 plus x to the power of 2 equals 3 to the power of 2. But also, y has to be positive or 0, and x is between 0 and 3, which means that it is a quarter of a circle of radius 3. If we don't have the restriction of x and y to be greater or equals to 0, we will get the whole circle. But in this case, because y is the square root of something, it cannot be negative, and also the limits of the integrals that are related to the x here are between 0 and 3. And because we know the region, we know how to evaluate this integral. Because everything is above the x-axis, this integral is the area of the yellow region, which means that it is the area of a quarter of a circle with radius 3, which is just 9 over 4 pi.